Hello everyone, this is Ms. Shaista Khanum from Vikramajan's College of Engineering and Technology. This video is a continuation of the previous video in which I've explained about how to make a layout of the single NMOS and PMOS. Now here we are considering CMOS. So in CMOS is nothing but formed with the help of NMOS and PMOS. Now this is same as like how we do the connection in a circuit. Now here you can see this is nothing but what source. This is source, this is source, this is drain, this is drain, this is gate, and this is gate. So what we have to do, we have to do the connection in a similar way. Now the only difference in this layout is nothing but shown horizontally, and now you consider it vertically. So this is same. So here first what we are forming, see over here first we are forming a end well. Why we are forming an end well? We know that because the whole background is nothing but a P substrate. So in that what we are doing, we are taking, this is nothing but I'm taking P diffusion and then I'm making a poly. So here you can see if this diffusion is crossed by the poly, transistor is formed. So either of this can be source or drain. So here I'll mark it as source because यहाँ मुझे vertically connect करना है source to VDD, and I'll consider this to be drain. Now next is nothing but what? Diffusion. Next is nothing but a diffusion. So this diffusion is nothing but end diffusion, and next what I'm doing, I'm making a poly. So here again this will be drain and this will be source. Now next what we are doing, we know that the gate of both the transistors are shorted. So what we are doing, we are doing this connection, and hence this is nothing but a gate. So this is nothing but what? VE. Now what next we need to do? Here we next, so this is shorted with the same poly gate. Now drain of both the transistors should be shorted. So here we are using, for making a connection, we know that we use a wire. So wire is nothing but a metal. So here we are using this blue color is nothing but for metal. So here we are connecting a metal, and this is nothing but what we can say over here is nothing but output. But when I'm making this layers over here also, then I'm taking it for VDD also again metal, and for ground also I'm taking metal. But please see that these black dots, what these black dots are, these are nothing but contacts. See, you are connecting this metal to the diffusions, but the connection is not made till you are making a contacts over here. So these black dots are nothing but a contacts. Next is like, if you see over here, if I'm following the circuit diagram, the area in layouts are wasted because this is nothing but what? Here you can see the poly is drawing a lot of area. So what we can do, and this is not the only circuit, like CMOS inverter is a base of any circuit. So when we go for a larger circuits, then the area requirement is going to increase. Hence, instead of this, we are following the horizontal method. So this horizontal method, what we are doing, you can see the same thing. What we are doing again, now I'm following the horizontal method in that here this is nothing but what? P diffusion crossed by poly, transistor is formed. Here I marked as the drain and here I marked as source. Then over here, so now what we are doing, this is drain, this is N diffusion, and this is P diffusion, and we know that well is required, so that is by default. Then what I'm doing, I'm making a poly. See, with the help of this, what is happening? See, in this, we were drawing the connection like this. It was quite large. But over here, this poly, only thing I'm extending it. So the area requirement is going to reduce. So what I'm doing, gate of both the terminals are shorted. So this is when this poly is crossing this diffusion. So transistor is formed. So this is nothing but what I'm considering as source. This is nothing but what? A drain. This is source. And this is drain. So now this is nothing but transistor is formed. Next what we need to do the connection. Now this source is connected to VDD, so I'm making a contact, and here I'm connecting a VDD. See, this is a very small circuit, hence I'm taking a contact directly connecting VDD over here. But when we go for NAND or the any realization, then we should go for a common VDD and common ground, how it is shown over here. The next is nothing but we need to short both the drains. So we need to short both the drains is nothing but we are taking a metal and we are connecting it over here. So this is nothing but what, a metal connection. And after that again we know that I'm doing a connection, but this connection will not be connected till you are making a contact. So here we are making a contact. So this is nothing but what, a contact, and here is VDD and here is ground. So over here this transistor is in this way, the CMOS inverter has been formed. Now and what we do, we see that here V in, we need to apply the V in over here. So here clock 1 I've written V in, and this is nothing but what, from where I'm going to take the output. So this is nothing but what, how we can make a layout. So now we'll see how we'll see in the next video how this layout can be made with the help of Microwind software. So thank you, and see the next video for the how it can be done with the help of Microwind.